this team points, memory points. Yeah, why you didn't join yesterday?
Same reasons that I was studying. Today I had a practice test in physics.
Oh, okay.
In ray optics and wave optics.
ठीक है. Okay. So today we'll discuss about inductive reactance and capacitive reactance. So as we saw before, inductive reactance XL equals to omega L. Now omega equals to 2 pi F or 2 pi by T. So 2 pi means 360 degree. So in 360 degree, what's the F here? Frequency. And L is the inductance. And what's the unit of inductance? What's the unit of inductance? SI unit of L, what is it? Samhita?
Don't ask me.
Henry. And frequency? Hertz. And omega equals to radians per second. Or radians hertz. Because hertz is 1 by second. So radians per second. And capacitance? What is SI unit of capacitance?
Faraday?
Yeah, farad. So XL and F, they are directly proportional. Frequency and XL. In this one, they are inversely proportional. F and XL. They are inversely proportional to each other. Because here XC is what? XC, sorry, not L. XC is 1 by omega C. So XC is your capacitive reactance. And here it is inductive reactance. So likewise, if you go with phasor diagram also, we saw before for resistor, they both are in same phase. Voltage and current. PR. Then VL and I, they are 90 degree back. VL is ahead of current. VC is behind of I. So in this one, they both are in same phase. In this one, they are 90 degree behind. In this one, they're 90 degree ahead. Means leading. Current is leading voltage. Here current is lagging. Here leading voltage. So what is the general equation of V equals to Vm sine omega t. Vm or V naught. So these are amplitude. amplitude or peak value. Peak value means maximum value of those we are whenever we are going like this. So this is the peak value of current in positive and this negative side. This positive and negative. Now, if we take average of this, obviously it will be zero because one is positive value, one is negative value. So it will become zero. Average of this one is zero. Okay, let's get back here. So current in a pure inductor lags EMF by 90 degree. That is what we saw here. They are lagging by 90 degree. Lagging means behind, and here leads by 90 degree. That's what we saw here. They are leading, current is leading the voltage. This is most important that for DC, direct current frequency is zero. So XL is zero because they are directly proportional. For DC, in capacitive circuit, frequency is zero. That means it will become infinite. 1 by 0 means infinity. So this all depends upon this relation, frequency and XL and XC. So in this AC, frequency increase, so XL also increase because directly proportional, here inversely proportional, so they go reverse way. Don't forget this unit, okay? These units are so important. Madhusudan,
Yes, sir.
did you attempt the test yesterday?
Yes, sir.
Okay, I didn't check the score yet. चलो ठीक है. Okay, shall I scroll?
Just a second.
Okay, no problem. Right.
Done, sir. You can scroll down.
Okay. Samhita done?
Yes, sir.
What about Madhusudan?
Done, sir.
So chalo next. See this one. This we saw about inductive reactance and capacitive reactance. Now, if you remember what is reactance, can you tell me what is reactance? What do you mean by reactance? Aditi? Yesterday you were there. Come on, tell me what is reactance? Do you remember?
So can you hear me?
Yeah, I can hear you. So do you remember what is reactance? No?
Saying something. I can't hear you. Are you saying something?
Yes, I am saying. Can you hear me now? Okay, nice. What about Madhusudan? Do you remember what we discussed? No? Simple, yeah. You can remember this. Reactance means a resistance offered. Means resistance in inductive circuit, resistance in capacitive circuit. So it is called capacitive reactance, inductive reactance. Reactance means resistance offered. So which reactance offered means resistance offered in inductive circuit, inductance or inductor, it is called inductive circuit or inductive reactance. That is XL. And resistance offered by capacitive circuit, that is called capacitive reactance. Okay, will you remember now? Yes? Or it is not blinking? Is my audio clear?
Yes, sir.
Okay. Because this was not blinking. Okay then. Now, next comes here resonance. Resonance means like, yeah, first let me ask you then I'll give you answer. Can you try what is resonance? Have you heard of this resonance anywhere?
Yeah.
You can say,
Chemistry.
sorry, where?
In chemistry,
Chemistry, okay. So what does it mean in chemistry?
the transfer of an electron charge, and yeah,
Okay. Okay, simple words. If I'm not going with definition wise, simple way, if I can say, like a matching frequency. Something is work, some frequency is going on, and some other frequency add on it. So it will make a matching frequency of something. So unifying. So as you can see here, they are unifying in this. XLN equals to XC in series resonance. When this is in resonance circuit, whenever they are in series, whenever they are connected in parallel, it will become XL 1 by XL by 1 by XC. So parallel resonance circuit. Here, this is series resonance circuit. Now, if we substitute both values from this, where is it? Yeah, omega L and here 1 by omega C. So it will become omega L equals to 1 by omega C. It will become omega square equals to 1 by LC or root LC. This is called resonance circuit or resonance when they have matching frequency. It is not a definition, but for just for understanding. So if you see here, I already wrote this one. omega equals to 2 pi f 1 by LC. So frequency equals to 1 by 2 pi under root LC. This is your V. V in the sense frequency V or F, whichever you can remember. Here it will become XL by XC. Or let's say like this, 1 by omega L equals to 1 by omega C. So omega C equals to 1 by omega L. Can? So and we can introduce here Z here. Z is your impedance. Impedance means total resistance of R, XL and XC. Impedance is total resistance, as you can see here. This is the formula. Okay, let's go next here. See, mostly, generally, or let's check here, generally, we will use this equation only. This will be used for as a equation because in exam, like mostly you will get series resonance circuit. Parallel, they won't. I've seen very few, like few times I've seen this parallel question. Okay, next. Electric meter can read both AC and DC. Even yes, that's what we saw yesterday only. In those scheme points we wrote. Max while adding voltage difference, current over complete cycle is 0. Okay, negligible resistance. Yeah, electric meter can read both AC and DC. That means this is electric meter is reading your RMS values. No, main difference of this, if I move it around, let me move this a little bit. This, any conductor, this is any conductor. Okay, if I pass a DC current, it flows with your electron. It moves electron like a uniform manner. Okay, now if I pass here AC current means like generally what is the AC current? When any charge particle of current, it moves here, it alternate means like how it is actually happening. This is just moving in straight path. Okay, normal path, direct current. But in AC current, it moves, it fluctuates, it moves front, it fluctuates, again moves front, fluctuate, and so on. So this fluctuation as we are drawing, it is like this. So this is your fluctuation part. So every cycle is changing, again changing, again changing, again changing. So it's reverse its direction. So reversing means like electron will say, okay, let's go back. No, let's go front. Not like that, but as they are moving from this movement, as they're passing here, it alternates current here, alternate direction, and move front. So this way it makes them to gain some more momentum and moves in the like a longer distance. It makes them to move in the longer distance. That's why you're using AC supply as our household supply. Okay, so DC source flows across the section of the conductor, but AC along the surface of the conductor. So that is the reason it depends upon frequency. So these were like small things about this chapter. Small topics. Can you hear me, right? You guys can hear me, no?
Yes, sir.
Okay. What about other two? Madhusudan and Aditi? Madhusudan?
Sir, can you hear me?
I can hear you when you are saying, can you hear me? After that, I'm not able to hear you.
Sir, I was trying to speak since a very long time.
Oh. No, I can hear only when you're saying can you hear me? That's it.
Sir,
After
actually,
that,
it's raining over here.
oh,
The mic is getting freezed when I'm trying to unmute.
Could you scroll up once?
oh yeah, sure.
Done, sir.
Samhita, yeah, you said last time like only mechanism is left, right? Mechanism and semiconductors.
Yeah,
Left in your-
mechanism, the 3 or 4 chapters are left.
Okay.
Yes, not the entire one. Like, we just started the 4th chapter in NCRT. So are we gonna do wave optics after this?
Yeah.
Okay.
No, but like after this, I want to finish wave optics. Then I want to go some 11th standard portion. Like those are also very important for your JEE. So some topics are like thermodynamics. I've listed some topics. I'm going by most weighted topics, then least weighted topics. I'll go at the end. So thermo will be the next mostly. No. Laws of motion not done, right? No. Kinematics done. Okay, let me see. Let me check. I made a note of it. Fine. Let's come back here. I'll post in a group only. What topics is next? So those who are like practicing, we can do it. Fine. Okay, so let's see this question. Then we can end because like your sir will be waiting next class. So we'll finish this. It's very easy. An AC circuit consists of, this is not JEE question. Okay, this is a normal practice question. AC circuit consists of only inductor means pure inductor. Inductance of 2 Henry. If the current in is represented by sine wave, okay, sine wave of amplitude 0.25. So this is your amplitude. If you remember what I said for amplitude, do you remember just now I said something when we started this today's class? I said something about amplitude. Tell me. Come on, guys. Don't disappoint me. Today only we discussed. What is amplitude? How to find amplitude in the equation?
Yes, sir.
So, which is the amplitude here?
Amplitude is 0.25.
Yeah, that's the value. Correct.
To
But-
substituted.
Where will substitute in place of what?
I naught.
I naught. So this is the amplitude. So amplitude is this one, frequency. So how to use this frequency here? Remember relation between omega? Omega equals to 2 pi f.
F.
So we will use this one 60 hertz to find omega.
Is time inversely proportional to that?
Yeah, frequency is inversely proportional to time. Okay. That is the standard equation to find out amplitude. What is the use of amplitude? So let's make a note of it. Okay, Henry, we have here, frequency we have, and amplitude of current we have. So, okay, now we have to see what is the question asked. Till now we saw what is the given terms and what is the relation between all these things we listed. See, if you don't get any idea, do this first. Get the list. Okay, these are the things I have. What to do now? Let's see. Potential difference means voltage. That's it. Calculate the effective potential difference across an inductor. Okay, inductor means we need VL. For that, what I said before, we will have VRMS value of given things. But here they have mentioned here it is as amplitude. If they don't mention, that is a VRMS value. But they mentioned here, so we will use as amplitude, means peak value of the current. Fine. So V equals to IR, and I by I naught, because this RMS value, so IRMS by √2 means IRMS to convert into this will give you IRMS value. This will give you IRMS. So this is the formula of the conversion. XL. XL means 2 pi. What is it? Omega L, right? Omega equals to 2 pi F. Don't get confused. V equals to IR. I and B, both are RMS value, so convert into this one. So I naught by root 2. R here, resistance here it is inductor, means XL. So XL I can write as omega L. So omega I can write as 2 pi FL. So finally, what are we getting? VRMS equals to I naught by root 2, 2 pi FL. So do we have I naught? Yes. Do we have this one? Yes. 2 pi F? Yes. L is given? Yes. That's it. Over. Multiply and divide by root 2. I naught is 0.25. Root 2 is, we can use 1.414 and 2. Oh yeah, 2 and root 2. You can make it as this one. And pi is 3.14. And 2 pi, we got it done. F is 60. Yes. L is 2. Khatam. Question is done. Can you finish the multiplication? Okay, have you written the question and formula? Aditi?
Yes.
Okay, Samhita?
Yes, sir, done.
What about Madhusudan?
Not done, sir.
Don't see answer, just do your calculation by yourself. Shall I stop sharing? Okay, guys, go for your next class.